In this video, we're going to be looking at notes, guided notes for Lesson A, Order of Operations and Percents and Decimals. We'll start with order of operations. Some mathematical expressions involve more than one operation. For instance, consider the expression 5 plus 3 times 2. This expression seems to have two different values depending on which order we perform the given operations. If we add first, we would add 5 plus 3 to give us 8, and then 8 times 2 is 16. If we multiply first, we would do the 3 times 2 first to get 6, and then 5 plus the 6 gives us 11. Therefore, in math, we agree to follow the rule called the order of operations so that everyone gets the same value as an answer. Here's our order of operations rule. Many of you have seen it before. To evaluate mathematical expressions, carry out the operations in the following order. First, we perform the operations within any grouping symbols, like parentheses or braces. Work from the innermost pair of grouping symbols to the outermost pair. Then we raise any number to its power. Next, we perform all multiplications and divisions as they appear from left to right. Finally, we do all additions and subtractions as they appear from left to right. Sometimes we use the mnemonic device, "Please excuse my dear Aunt Sally," with the P in please standing for parentheses, which we should do first, the E in excuse standing for exponents, my dear with the M and D standing for the multiplication and division, which we do in the same step from left to right, and Aunt Sally's, the A and S, standing for adding and subtracting from left to right. Now, when we want to evaluate an expression using the order of operations, we will either say simplify or evaluate. Those will be the instructions for us. So let's look at some examples. In example 1, we see that our expression is 20 minus 18 divided by 9 times 8. So using our order of operations, please excuse my dear Aunt Sally, we know that we do parentheses first, which there are none here, exponents, which there are also no exponents. Multiplication and division comes next. So I do see a division and a multiplication, and we do everything from left to right. So this is what we'll do before combining with the 20. We'll bring down our 20, and from left to right, we have 18 divided by 9 is 2. Then we're going to multiply that by 8. So we'll have next, we still have to do multiplication and division. 2 times 8 is 16, and 20 minus 16 is 4. Try this next one. Why don't you pause the video and let's see what you get. All right, so here we have 8 divided by 2 plus 4 times 3. Again, there's no parentheses or exponents, so we start with multiplication and division from left to right. So 8 divided by 2 is 4, and 4 times 3 is 12. So we've performed the multiplication and division and can move on to addition and subtraction, which gives us 4 plus 12 is 16. Let's look at a couple pair that are a little more complicated. In example 2, let's write our order of operations, parentheses, exponents, multiplication and division, addition and subtraction. So here we do have parentheses with the 8 plus 3 squared in parentheses. Before I can perform the addition of 8 plus 3, we have to take the exponent, which would come first. So we're really going to have 8 plus 9 in here. 3 plus 2 times 8 plus 3 squared, which is 9. Now we still haven't accomplished our parentheses duties here. So 8 plus 9 gives us 17. Now this 17, the parentheses have been taken care of. So next we move on to any exponents, which there aren't any now, and we'll go on to multiplication. So we have 3 plus 2 times 17 is 34. We do that first. And 3 plus 34 will give us 37. Let's have you look at B, pause the video, and then let's give it a try together. So in B, we have in parentheses 4 plus 1, then squared, minus 4 times 6. Again, we do have parentheses, so that comes first, and we'll have 5 squared minus 4 times 6. The next step is exponents, so 5 squared is 25. Then multiplication and division from left to right, where we have our 4 times 6, we'll put 24. And finally, we can subtract 25 minus 24 is 1. So we've gone through a few examples, and you'll want to be working on these on your worksheets and seeing how you do. The next concept we're covering in these notes are percent to decimal conversions. Now, the word percent, per means out of, and cent means 100. Therefore, if we write 22%, that means 22 out of 100, or 22 divided by 100. If we divide 22 by 100, we get 0.22. A shortcut is to realize that dividing by 100 means we move the decimal 2 places to the left to convert a percentage to a decimal. Let's look at example 3. In example 3, if we want to convert these following percentages to decimals, it's like we're dividing them by 100. So we move the decimal 2 places to the left. And on 75%, currently the decimal is behind the 5. Moving it 2 places to the left, we're going to 0.75. That would be our number as a decimal. And we can write a 0 in front of there if we'd like. On B, we have 5.3%. The decimal is between the 5 and the 3. Moving it 2 places to the left, we'll have to add a 0 in front of our 5. So 5.3% becomes 0.053 as a decimal. You can put a 0 out in front if you like. You don't have to. 250%, the decimal is behind the last digit, so it's behind the 0. If we move the decimal 2 places to the left, we'll get 2.5. That's our decimal number representing 250%. And with 0.76, the decimal's in front. If we move it 2 places to the left, we're jumping over 2 imaginary zeros, which we have to add into our answer. So our answer is 0.0076 is the decimal number for 0.76%. So it's very small, it's less than 1%, and that's why our answer for our decimal number is so small. Now, to convert a decimal number to a percentage, we do the opposite. If we multiply by 100, well, we will multiply by 100. The shortcut is to realize that when you multiply by 100, you move the decimal 2 places to the right. As an example, if I took 5 times 100, if I had 5 $100 bills, I'd have $500. That is the same thing you would get as if you took the 5 and moved the decimal 2 places to the right. So let's, in example 4, convert these following decimal numbers to percentages. So with 0.05, if we move it to a percent, we'll jump 2 numbers and have 5%. For 0.67, if we move the decimal 2 places, we'll have 67%. Go ahead and do C and D and then pause the video and we'll look at the answers together. So for C, if we move the decimal 2 places to the right to convert 0.003 to a percent, we're going to have 0.3%. And for 8, we put the decimal behind it. If we move it 2 places to the right, we'll actually have 800%. So the whole number 8 is, as a decimal, becomes 800 as a percentage. All right, let's look at the table below. We've had a few examples here. I'm going to ask you guys to pause the video and fill out the table, and then we'll check it together. All right, let's see how you did. 75%, the decimal's behind the 5. We move it 2 places to the left, so we get 0.75 as a decimal. 0.03, to change it to a percent, we multiply by 100, moving the decimal 2 places to the right, so we get 3%. Same with 9. Multiplying it by 100, we get 900%. 2.3%, to convert it to a decimal, we move the decimal 2 places to the left, so we'll have 0.023. 150%, if the current decimal is behind the 0, so if we move it 2 places to the left, we'll have 1.5. With 37, the decimal number 0.374, we're going to multiply that by 100, so we move the decimal 2 places to the right to get 37.4%. For 1.3 is our decimal number, we get 130%. For 0.5 as our decimal number, that's 50%. And this one had the decimal in front. So this 0.16%, that's not even 1%. It's very small. So when we divide by 100, we move the decimal 2 places to the left and get 0.0016. I hope you were successful and that you found the video helpful with order of operations and percents to decimals. See you next time.